Exploring the Solar System Part 3, using telescopes to see what's out there. So telescopes have been around for 400 years. I'm not going to go through all of that history, but I'll say something about the early views of the solar system through early telescopes and look at some of the latest views of the solar system, and then again ask the question, what next? So 400 years of telescopes. It's been 400 years since Galileo and others pointed their telescopes to the skies, and Galileo was one of the first to record what he saw. Since then, telescopes have developed in leaps and bounds, getting, generally speaking, larger and larger and larger. In the last century or so, we've started to see monster telescopes not using lenses a few centimeters in size, but starting to use mirrors, because technologically they're easier to make large mirrors than it is to make large lenses. And now we're talking about telescopes with mirrors that are measured in meters. This one, 2.5 meters in size. The Hale telescope, 5 meters in size. So the telescope at the bottom of that telescope, roughly the same size as the Mars globe behind us. Of course, even that, the largest telescope in the world when I was a child, that has now been overtaken, not necessarily in terms of size, but in terms of efficacy, in terms of what it can do, has been overtaken by not only telescopes that have larger mirrors, but telescopes that have been placed in space. That doesn't necessarily mean they collect more light, but being above the Earth's atmosphere means they're not looking through a rather turbulent atmosphere, which means the images are sharper. So that's the advantage of having things like the Hubble Space Telescope or the James Webb Space Telescope. Yes, larger is always good in terms of collecting more light, but going above the atmosphere was a sea change in terms of being able to get nice, sharp views of distant objects. Some of those objects within our solar system, some of those objects elsewhere in the galaxy, or indeed other galaxies in the universe. And it won't be too long before we have some really, really big telescopes coming online, such as, for instance, the European Extremely Large Telescope. Ridiculous name, but they started running out of names after the Very Large Telescope. Now it's now the Extremely Large Telescope, and I'm sure you can't see from where you are, but these tiny specks in the foreground are people. So this mirror is 40 meters in diameter, absolutely vast leviathans of telescopes that will be coming online in the next few years. Sort of 2027, maybe 2028, that sort of time period. So what did Galileo see when he first turned his telescope on various objects within our solar system? He looked at the stars and realized there's lots of stars out there. When he looked at Jupiter, he said, for our own eyes, show us 4 stars wander around Jupiter as does the moon around the Earth. So he realized that some objects were going around Jupiter. He made little drawings of Jupiter and stars that appear, little stars that appear to follow Jupiter. It wasn't just an accidental line of sight. Wherever Jupiter went, these little stars went, these little moons. So objects appeared to be going around Jupiter, which then proved effectively that not all objects orbit the Earth, and hence the idea that some religious doctrine said that the Earth is the center of everything. That was proved incorrect by Galileo and others, documenting the fact that they could see these little moons orbiting clearly something which was not the Earth, in this case orbiting another planet in the solar system, Jupiter. So absolutely critical experiments that were done by Galileo, observations that were made by Galileo 400 or so years ago. And when it came to Saturn, well, there was a certain amount of confusion there as to what it was they were looking at. The first sight I had of Saturn was 3 round stars, middle bigger than the lateral ones. We have to remember that telescopes of 400 years ago were not the same quality as telescopes that can be built today with modern instrumentation and modern manufacturing, either of the lenses or of the mirrors. So Galileo didn't have the best of telescopes by modern standards, and so perhaps it wasn't surprising that he was a little confused as to what it was exactly he was looking at. There was nothing else in the solar system to give the same appearance as Saturn. And for decades thereafter, lots of people turned their telescopes on Saturn and couldn't figure out what it was they were looking at. Does Saturn have ears? Does it have a couple of big moons on either side? Well, it wasn't until about 1659, some decades later, that Huygens finally said, I think I know what we're looking at. We're looking at a sphere, a ball, with a ring around it. And when you look at that particular drawing, only a few decades after Galileo, if you compare that with a modern view of Saturn, you realize he was absolutely spot on in terms of what it was he was seeing. So the optics weren't great in those early telescopes, but with a bit of imagination and some careful observations, you can still figure out what it is you're looking at. There was also a great deal of controversy when it came to looking at Mars. Yeah, Mars is just a planet on its own. It doesn't seem to have visible moons, or at least not visible in early telescopes, and it doesn't seem to have rings. But what's going on the surface of Mars was a great deal of controversy at the time. Schiaparelli did some drawings in the 1880s or thereabouts, over 100 years ago. He said, well, I can see various features on Mars, and I can see these straight lines, these canali, channels as he wanted to call them. And he showed the detail there and said, look, we've got all of this detail, there's definitely these channels. But unfortunately, the Italian for channels is canali, and some people treated canali as canals. As soon as you say canals, that implies they're artificial, as opposed to channels, which could in principle be made by flowing water, for instance, natural flowing water, rather than manufactured by whoever the inhabitants of Mars happen to be. And that was part of the problem. Maps started to be made of Mars that clearly showed lots of these straight lines, these channels, these canali. And the question was, well, are they actually irrigation canals bringing water from the pole to the equator? Why don't people just live at the pole if that's where they want water? Why do they live at the equator and build canals? But the work of Schiaparelli in the 1880s led to lots of other people looking at Mars and saying, yeah, I can see those canals as well. Some people looked and didn't see them. Some people looked and did see them. So rather than simply saying, well, we're not actually sure if they're there or not, plenty of people were convinced that they are definitely there, they are definitely real, and yes, if they're canals, they are definitely artificial. So the only verdict you can come to, and this was picked up by the American Lowell in the 1890s, well, clearly there are Martians out there. There can be no doubt that living beings inhabit our neighbor world. That's a very strong statement, even for the so-called greatest authority on the subject. I'm not sure if he said he was the greatest authority on the subject, or that's what everybody else said. But it's an indication of how easily you can be fooled, because it's generally thought that these canals don't exist, and the only reason you might see them is, well, it depends on how you do the observations. Lowell was using this very large telescope, large lens at the front, very high magnification, tiny amount of light coming out of the eyepiece into his eye. Perhaps what he was actually seeing when he sat there at his telescope to do these observations, perhaps he was just seeing vague features on Mars, but bear in mind what's going on the back of your eye. You've got lots of blood vessels there, and sometimes, depending on how you look through a telescope, it is possible that these blood vessels get highlighted. If anybody's had their eyes tested and the optician shines light into your eye, you tend to see your blood vessels. Maybe that's what was happening. Quite how you end up mapping it so that they all seem to be in a particular place, well, it looks like it's not exactly mass hysteria, but perhaps it's the sense of suggestion. As soon as somebody says it's there, some people will say, oh, yeah, I can see them. But eventually it wasn't too long before it was realized that what Schiaparelli said were very straight lines, these channels. Other people looked and said, well, I can see something, but they're not straight lines, and there's certainly no indication that they are artificial. So the old maps of Mars got basically rewritten until now we can use the Hubble Space Telescope and look at Mars, and we see lots of interesting features, but we don't see canals, we don't see straight lines. We see certain features, some of them look vaguely linear, but on the whole they look like smudges and craters and dark areas and light areas and polar caps, but we don't see canals. Bit of a shame. It would be more interesting to think that there were Martians up there digging canals. Amateurs can build themselves telescopes, or these days buy themselves telescopes at very reasonable cost. In the past, it was very expensive to buy telescopes, and so a lot of amateurs made their own. These days, amateurs, lots of amateurs around the country, even in a country like England, which doesn't have the clearest skies every night of the year compared to other parts of the world, amateurs will buy themselves refracting telescopes that use lenses or reflecting telescopes that use mirrors. There are also a breed of telescopes in this overlap region in the middle there, which use lenses and mirrors. They're called catadioptric, or CATs for short. Amateurs have a huge number of telescopes to choose from. It's bewildering. If anybody is thinking of buying a telescope, be careful, because there are thousands of them out there, and choosing the best telescope for doing whatever it is you want to do, well, that's a bit of a minefield. Amateurs, depending on the depth of their pockets, might start with small telescopes and might, after a little while, end up with huge telescopes. And if you're finding it difficult to judge how big that telescope is, that gives you an idea. And yes, you will need a second mortgage to buy a telescope that size. But they are available either for individuals or for universities or other societies that want to invest in very sophisticated amateur equipment. So why this drive to go for larger and larger? Is it simply the kudos of having the biggest telescope in the region? No, there's a good reason for wanting to get telescopes with larger apertures, either larger lenses or larger mirrors. It's twofold advantage. One is you can collect more light, which means you can see fainter objects that are out there. But also, the larger the telescope lens or mirror, the more detail you can see. So not only can you see further because you can see fainter objects, you can see more detail on those objects as well. So it's a double whammy. So not only are amateurs always trying to get the largest aperture telescope that they can afford, or their wife lets them afford, there's also the same with professionals. They started, this is an indication, this graphic shows you the size of telescope mirrors. The top left is not Galileo, the top left is a telescope with a lens about 1 meter in diameter. It's already a huge telescope, but that's that dot in the top left. And the scale here, they're all to the same scale, and there's a human down here you can hardly make out. They're just a couple of pixels. And if you're, again, having difficulty with the areas, that's a basketball court in the bottom right, and that's a tennis court just peeking up in the bottom left. That gives you an idea of the size of these things. So this telescope here, this donut, represents the size of the mirror of the largest telescope in the world when I was born, and the largest telescope in the world for most of my adult life. That's now been overtaken by that one. That is currently the largest telescope in the world. It's made up of little hexagons rather than one big mirror, because it's just easier to make that way. And that's about 10 meters or so in diameter. The largest telescope in the world is sitting on the Canary Islands, on La Palma, Gran Telescopio Canarias. The telescopes that we put into space, we would like to have a telescope that size in space, but it's just too difficult to put on top of a rocket. So space telescopes actually have rather smaller mirrors. So for instance, the Hubble Space Telescope is tiny, and even the James Webb Space Telescope, some 6 meters in diameter, is small compared to the telescopes that are currently in use on mountaintops around the Earth, or telescopes that are being built in the very near future. And you can see that there are a couple of very large ones coming online before too long. The 30-meter telescope, any guesses as to how big that is? 30 meters in diameter, again, no imagination, these astronomers, and the European Extremely Large Telescope. So that one is American, planned to be built in Hawaii, and this one is European, being built in Chile. And it looks like the Europeans are winning. Hurrah. And just out of interest, this thing in the background, this gray object here, is the idea of, could we ever afford a telescope that big? Not 40 meters in diameter, but 100 meters in diameter. Well, they've sort of mapped it out, and they said this will be very expensive, but if we did want to build it, this is how we would build it. And they decided to call it the OWL, the OWL, not because owls have large eyes, but because, having dealt with the Very Large Telescope and the Extremely Large Telescope, the OWL would be the Overwhelmingly Large Telescope. And again, limited imagination. No money to build that, but the 40-meter telescope will be coming online. At the moment, they say it's planned for 2028. Still another couple of years to go, but it will be fantastic when it will be able to collect so much light. So the ELT is the next really big telescope here on Earth, the Extremely Large Telescope. So that's the Hale telescope. I use that as a reference because that's 5 meters in diameter, the main mirror down there. There's no people in this picture, so you can't judge it. But the 5-meter mirror at the bottom is about the size of the Mars globe behind us. And as I say, that wasn't overtaken as the largest telescope in the world until the 1980s, 1990s. So where are these big telescopes? Well, there are certain places in the world where it's worth putting a big telescope. Liverpool, Manchester, Norton are not one of them, unfortunately. If you're going to have a big telescope, you want to put it where it's going to do the best good. And the best observatory sites in the world are either volcanic islands, such as Hawaii, for instance, which is where the Americans prefer to put their telescope, or La Palma, Tenerife, belonging to Spain, but obviously relatively close to Europe, so there are a number of European telescopes positioned there. And also the Atacama Desert in Chile is favorite because the Andes there, very high mountains, very dry atmosphere, so you don't have much water vapor to get in the way, and you're already quite high, so you're already not looking through most of the Earth's atmosphere because you're at an elevation of many thousands of meters. If we have a look at a site in Chile, that gives you an idea of what it's like. You put your telescope on a mountain like that because, as you can sort of see from this picture, a lot of the atmosphere is already below you when you're at thousands of meters altitude. If that's not high enough, if you really do need to get higher, well, one option is to put it in the back of a 747, and that is the Stratospheric Observatory for Infrared Astronomy, where they put an infrared telescope in the back there and a whole load of instruments in the rest of the section. That particular 747, owned by NASA or run by NASA, is now being retired, partly because the James Webb Space Telescope is an infrared telescope sitting above the atmosphere, so we don't need to fly an aircraft like that at 10,000 meters to get above as much atmosphere as possible. You're better off just putting something into space. So this has now been decommissioned, so watch out on eBay. This might be appearing as a bargain at some point. But now we have space telescopes. We've had the Hubble Space Telescope since 1990. Yeah, 1990. It's been with us for 35 years now, the Hubble Space Telescope. And the James Webb Space Telescope was launched much more recently on Christmas Day 2021. Because it has a much larger mirror, it was problematic. It had to be built in the lab and then folded up like a piece of origami so that it would fit on the top of a rocket, then launched into space, and keep your fingers crossed that it unfolds correctly back into its original shape. So it's amazing the technology that was necessary to get it to fold up and then unfold at a distance of 1 million miles away. It's sitting 1 million miles above the midnight position of the Earth. And it gives us different information. The Hubble Space Telescope shows what things look like in the visible part of the spectrum, but either side of the visible, we've got the ultraviolet and the infrared, and the James Webb Space Telescope works in the infrared for a number of different reasons, partly because it allows you to see further into the universe. Some very distant galaxies are brighter in the infrared than they are in the visible. So if you work in the infrared part of the spectrum, you can see fainter galaxies from a greater distance. You can look further back in time to the very early universe. Also, working in the infrared allows the James Webb to look at systems that are in the process of forming. For instance, as a planetary system starts to form around a star, it's a very dusty environment. Infrared cuts through dust much more effectively than visible light does. So there's lots of reasons why you might want to work in the infrared. But when we look at our immediate neighbors like Jupiter, we see, yes, in both cases we can see that there are cloud systems, but we can also see different contrast. Here we're seeing reds and oranges, presumably from sulfur and phosphorus and other elements being dredged up from lower latitudes. In the James Webb Space Telescope, we're seeing a different contrast, so it gives us different information about what molecules, what elements are in the atmosphere, and hence what's actually going on. As a side, we also notice this red tinge on the top and bottom. That's not an error of the image. That shows us that there are aurora, northern lights and southern lights on Jupiter. Jupiter has a very strong magnetic field, and just like the Earth's field tends to focus particles emitted by the sun, which produces aurora borealis, so it seems to be happening on Jupiter as well, which can be seen in the infrared. If we compare Saturn, for instance, that's the Hubble version of Saturn, the HST, the Hubble Space Telescope view of Saturn. What would that look like if we switched to infrared? Well, perhaps it's a bit surprising to realize that the planet almost disappears, and yet the ring system is very bright in the infrared. That's because the ring system is lots of tiny particles of ice which are very effective at scattering and emitting certain wavelengths of infrared light, whereas the planet itself, mainly made of hydrogen and helium, doesn't tend to emit much in the infrared part of the spectrum, especially as it's so far away from the sun. So again, we get a very different perspective by looking at planets with different part of the electromagnetic spectrum, whether it's visible light or infrared light. When we look at Uranus, what do we see? Well, we see that Uranus has a ring system that looks almost as spectacular as Saturn's ring system. It looks a lot brighter in the James Webb than it would do in a visible telescope like the Hubble Space Telescope, again, because the nature of what the ring system is. The ring system is a huge number of tiny particles which are very effective at emitting infrared light. As it happens, we also see a bright spot on the left. That indicates there's a storm system on Uranus. Voyager went past Uranus, but it only spent a few hours doing that because it was moving so fast as it went on its way to Neptune. It only had a few hours to map out the surface of Uranus. And therefore, if it just so happened that there was no storm systems on Uranus, Voyager got a very boring view. It sort of saw nothing as it went past the planet. Whereas if we can watch Uranus from Earth as often as we like, that's the difference between a telescope on Earth and sending a spacecraft. A spacecraft flyby is a very brief encounter. On Earth, we can go back and keep looking at planets essentially as often as we like to see what's going on, how is it changing. We can do the same with Neptune, and lo and behold, Neptune has a ring system as well, perhaps not as spectacular as the other two. And in this particular case, not only is Neptune quite bright, one of its moons is insanely bright. That's because this particular moon, called Triton, this moon, the largest moon of Neptune, happens to be essentially nitrogen ice. And again, nitrogen ice is very reflective in the infrared compared to most other types of material or composition. So in this particular case, again, the ring system shows up nicely, and we get a very bright spark here, a very bright spot. This characteristic star shape is characteristic of any image that comes out of the James Webb Space Telescope because of the nature of its optics having hexagonal segments rather than one big circular mirror. So where are things heading in the future? Well, there are a number of really interesting telescopes coming along online fairly soon. This is a really interesting time for astronomy in terms of what the professionals are up to. This is an object called the LSST, which goes by the unpronounceable Large Synoptic Survey Telescope. It's since been renamed the Chamonix Telescope, and they're talking about a survey that they are going to do with this telescope, which they now call the Legacy Survey of Space and Time. In other words, they're reusing the same acronym. That means that lsst.org, they don't have to throw away that web page. They can just keep the same one and give it a new definition. But this is a telescope with a huge mirror and an even bigger camera. It's a humongous camera because they want to be able to map out the sky quickly. If you want the Hubble telescope to map out the sky, because it has a tiny field of view, it would take 100 years for the Hubble Space Telescope to map out everything that's out there. This telescope can effectively map out the entire sky every 3 days. In other words, it will just keep looking at the sky, and the next night it will look again, next night it will look again, and it will keep doing that night after night after night after night for 10 years. So it will map out the entire sky, it will see billions of stars and billions of galaxies, and it will see how they change from day to day, week to week, month to month, year to year. It will find new objects in the solar system. It'll probably find more new objects in its first night of observation than we've seen with all the previous telescopes put together. It's thought that it will probably find thousands of new solar system objects every night that it runs for the entire 10 years. Some of those objects will be quite small. Some of them could be large enough objects that if they're heading our way could be a serious threat. So we have to be able to monitor these things. The camera itself is about the size of a car. You can see its size here relative to a human on the right-hand side. And it's going to be operating, hopefully, from this year. If all the calibration and everything else goes to plan, it should be operational later this year or perhaps early next year. And it will run continually mapping the sky for 10 years. And then it will tell other telescopes what to look for. In other words, it'll look at the entire sky, it'll find lots of interesting objects, and then it will tell other telescopes, go look at that, that looks interesting. Go look at that, that looks interesting. And it will be feeding that information to telescopes such as the European Extremely Large Telescope with this humongous mirror, which will be able to see in more detail. Again, it will have a narrow field of view, but it will be told what to go and look for by survey telescopes, which are mapping the entire sky. And again, you get the impression from a person, two people standing down here, a couple of people here on the gantry, you get the overall scale of just what a monster telescope this is going to be. And hopefully first light in 2028 or thereabouts for this. It's well underway in terms of construction on top of a mountaintop in the Andes of Chile. So again, if you want to know more, every picture taken by the Hubble Space Telescope for the last 35 years is available from the Hubble site. Everything that the James Webb Space Telescope is doing, there's a little bit of a delay, a few months while the scientists analyze the images they're getting, but then they become public. So if you look on the James Webb web page, if you get my drift, the web, then you find all the information about what the Webb has been doing for the last 3 years since it was launched in 2021 and what it is planning to do in the future. And if you want to know about the future, then the LSST, the Large Synoptic Survey Telescope, or the Legacy Survey of Space and Time, the Survey Telescope will be coming online soon, and the European Extremely Large Telescope, they must find a better name for it than that, again, will be coming along online in a few years. So you can find information about the past and the future by exploring these web pages. Thank you very much.